All right, so again, this is going to be aKS 22 on your test. It's just a review, so this is a way to remediate. This is a way to replace. So we're going to focus on number 3. We have 3 different ways that we can solve. We can either use a quadratic formula. You can solve by square roots. And you can factor. Those are the 3 ways to do it, okay? So the first thing I want to do with this one is I want to make sure that it's in standard form. Okay, what I mean by standard form is that whole ax squared plus bx plus c equals 0. Yeah, where everything's on one side. Okay, so we're going to add 7x and add 6 to the other side. So we're going to add 7x and add 6 to the other side. So if I rewrote all of this mess, I'm going to get 11x squared plus 7x plus 6 equals 0. Say it again. I added everything to the other side. Okay, and the reason why is because I want it in that ax squared plus bx plus c thing. All right. So if I look at this, am I going to use the quadratic, solve by square roots, or factor? Well, I'm definitely not solving by square roots. That's not happening because there's not a square root here, or like a perfect square. Let's see if we can factor. Okay, so let me think about it really quick. I would do a times c, so 11 times 6, that would give me 66. My b would be 7. I don't know about y'all. I can't think of a number that will work for. So you know what I have to do? Quadratic formula, right? Okay, so for those of you who are like, I don't remember the quadratic formula, here it is. Negative b plus or minus square root plus or minus square root. No? Okay. B squared minus 4ac, b squared minus 4ac all over 2a. Yeah. Okay. So now what you're going to do, now you're going to have that as your ringtone. It's fine. All right. So you're going to plug in all of these numbers and then you're going to simplify. Okay. So if I plug in 7 for b, I'm going to get this. If I plug in 11 for A, 6 for C, all I'm doing right now is like substituting in the numbers that I have. Okay? With me so far? Okay, so now what you're going to do is you're going to simplify underneath the radical. So 7 squared, y'all know, is 49. Okay, and 4 times 11 times 6, 264. So that's going to give me negative 264 all over 22. Okay? So again, still want to simplify what's underneath the radical. So I'm going to do 49 minus 264. Somebody help me out with that. Yeah. No. All right. 49 minus 264 is negative 215 over 22. Okay. Now, you could simplify this down, okay? But what you're going to find out is you can't simplify it anymore. So the only thing that we need to do is we need to write negative 7 plus or minus I square root of 215 over 22, okay? The reason why I'm writing this I out here is because you see that negative underneath the radical? We know that the square root of negative 1 is I, right? Thanks, Mom. Appreciate you. Okay, so that's why we're going to put that I outside and we're going to make it positive. Okay, so on number 2, what's going to happen is we've got to make sure that this is in standard form. So we're going to move all of this mess. Actually, we're going to move that 3x to the other side. And it really doesn't matter which side you move everything to. You just got to make sure that your negatives and positives are good to go. If you're moving something to the other side, you change the sign. Okay, so when I do this, this actually cancels out, right? And so if I want to write this in standard form, I'm going to put that negative 12x squared minus 108 equals 0. Okay, we don't have a b term now. Okay, so whenever you don't have a b term, my suggestion to you is to solve by square roots because it's just going to make it a little bit easier. So what I mean by that is I can add 108 to both sides. And that's going to give me negative 12x squared equals 108. Now, my goal is to get x by itself. So I'm going to divide by negative 12 on both sides. And that's going to give me x squared equals negative 9. Okay, because 108 divided by negative 12 is going to give me negative 9. I still want x by itself, so I'm going to take the square root of both sides. So x is going to equal a positive and negative 3i. The reason there's an I there is because there's a negative underneath the radical. Okay? So now what you're going to do for number 4 is you're going to put it in standard form. Well, guess what? This is already in standard form. You just need to put that 0 on the end, right? Yeah? Y'all are so excited to have quadratic functions, I know. All right, so now we're going to see if we can factor this guy. All right, so a times c is going to give me 36, and b is going to give me negative 5. What two numbers will make that happen? You were close. What is it? What'd you say? 4 and? Close. Negative 9. All right, so we're going to have to use the box method for this, guys, because look at this guy right here. You see it? You see it, Mr. Krabs? Okay. You feel it now, Mr. Krabs? All right, so for the a term, we're going to have something bigger than 1. So that means that we're going to have to put it in that first box, and then we're going to put that last term in the last box. Okay? And these two terms that we just found, we're going to put them right here and right here. No, these can switch. These diagonals can switch. Okay? So now we're going to take the greatest common factor from each row and column. There's so many. Okay, so we just pointed out the fact that there's no negative in front of this, right? So that's not going to work. So what do we have to do now? We're going to have to do the quadratic. Yes, we love that. So negative b plus or minus the square root of b squared minus 4ac. Wow, look at that 4ac. All over 2a. Looks like a moose. All right, so yeah, it's fine. All right, so we're going to plug in negative 5 for all these b's. Okay. So that's going to give me this mess. Like, all I'm doing is plugging in these numbers. Wow. Look at this handwriting. Who lets me teach? Okay, so once we've substituted everything in, then what we're going to do is simplify the outside, inside, and the bottom. Okay, so let's take the outside first. So we've got this negative and a negative. That's going to be a positive. Okay, and then underneath the radical, this negative 5 squared is going to give me 25. Negative 4 times 6 gives me negative 24. And then negative 24 times 6. What is it?
Negative 144.
This would be negative 144. All over 2 times 6, which is
12.
Boom. All right, so what? Oh, no. All right, so 25 minus 144. What is that going to give me?
Negative 119.
All right, so we're going to have negative 119. I can write, I promise. Over 12. Yes. Okay, so all you're going to do to write this out, since there's no factors of 119 and we can't break this down anymore, like we can't simplify the radical, we're going to write this as 5 plus or minus I square root of 119 over 12. And somebody just asked why this becomes positive. Because we pull out that I. Remember, back from unit 1, I equals square root of negative 1, right? So when we pull out that square root of negative 1, we are left with a positive. Yeah? Okay, so now this is aKS 14. Okay, so this is like long division and synthetic division. Okay, so the difference between long and synthetic is, look at this first term right here. Okay, you see how it's a 1? And there's no exponent right up here? Yeah? Okay, so then we can use synthetic division on this guy. So what we're going to do is we're going to change the sign. So that's going to give me negative 2 right here in the jail cell, right? And then we're going to write out all the coefficients of the other one. With me so far? All right, let's see if I can get color fancy with this one. Okay. Color fancy. All right, so we're going to bring down this first term. Then we're going to multiply negative 2 times 1. That's going to give me negative 2. I'm going to add together these two numbers. So 4 plus negative 2 is going to give me 2. I'm going to multiply negative 2 times 2. That's going to give me, and then I'm going to add those together, and that's going to give me a whole 0. Okay? Okay, we ready? What? That's a 0 right here. Okay. All right. So now what we're going to do is we're going to drop it down one exponent, right? So we're going to drop it down to an x plus 2. So if it was to ask you, hey girl, hey, what would you get after you divide these two? You would be like, x plus 2. Okay? What this tells me though, and this is like the big takeaway. You see how this is 0 right here? Okay? That means that x plus 2 or x equals negative 2 is a 0, a solution, a root, an x-intercept, if you will. Okay? Wow. So much yelling. Okay? So, please, 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 please. There's going to be some type of question that's like, hey, if you have a remainder of 0, what does it mean? Those 4 words. Okay? 1, you're going to have to do long division on this guy. Okay? And I would bet money that on your final exam, they're going to do something like this, because this is crazy. All right, so the first thing you're going to do is you're going to put it in the house. So you're going to be like, oh, this mess. Okay? You want to make sure that it's in descending order, as well as you want to make sure that all exponents are accounted for. So you see how it's like 4, 3, 2, 1, blast off? Yeah? Okay, so then you're going to take the stuff that's over here. You're going to write it outside of the house. Be like, hey, girl, hey, go out there. Okay? So now what you're going to do is you're going to take this first term right here, and you're going to divide it by this term right here. Okay? So if I take 4x to the 4th, and I divide it by 2x, what am I going to get? 2x to the 3rd. And I'm going to put that right here on top of the house. Okay? All right? So then what we're going to do, and this is the part that y'all always forget. We're going to take this guy that we just found, and we're going to multiply by everything out here.
Oh, everything.
Yep. Okay? So when we do that, we're going to get 2x to the 3rd times 2x. That's going to give me 4x to the 4th. 2x to the 3rd times negative 1. That's going to give me negative 2x to the 3rd. We're going to draw our line and change our sign, which means that we're going to subtract.
Bless you.
When we subtract, this stuff got to cancel out. Then we got, I'm going to need you to quit sneezing. No, I'm just kidding. 3 minus negative 2 is going to give me a positive 5x cubed. 3 minus negative 2 is going to give me a positive 5x cubed. And then we're going to bring this guy down right here.
Okay.
So now we're going to repeat that whole process. So this is the part where a lot of you are going to have some trouble because we're going to have to deal with fractions. Sorry. Okay, so 5x to the 3rd divided by 2x is going to give me 5 halves x squared. Okay, so here it is again. Let me run that back. 5x cubed divided by 2x, you're going to get 5 halves x squared. Yeah. I would leave it in fraction form because that's probably how you're going to see it. So now you're going to take this guy and you're going to multiply by everything on the outside. So 5 halves x squared times 2x is going to give me 5x cubed. 5 halves x squared times negative 1 is going to give me negative 5 halves x squared. We're going to change our sign and draw our line. So these guys are going to cancel out. 2 minus negative 5 halves. So that's going to give me 9 halves x squared. And we're going to bring this guy down. Now we're going to repeat that process. So you have 9 halves x squared, and you're going to divide it by 2x. So you're going to have 9 halves, and we're dividing it by 2. So you're really taking 4.5 and dividing it by 2. Yeah. So that's going to give me 9 over 4 x. So when I multiply this back out, I'm going to get 9 halves x squared. Over here, I'm going to have negative 9/4 x. When I subtract these are going to cancel out. I'm going to be left over with 1